Hey everyone, it's Justin again. In this video, we're going to be working through some more examples on how to calculate domain restrictions for functions. In the last video, we said that if the variable is in the denominator of a fraction, you could find the domain restrictions by setting the denominator not equal to 0. And if the variable is under a square root, we set the radicand, the part under the square root symbol, greater than or equal to 0. Let's take a look at this function, square root of negative 4t. What in this function might cause the domain restriction? The variable is underneath the square root. So what's the rule for a square root domain restriction? The radicand has to be greater than or equal to 0. To solve this, we just divide both sides by negative 4. 0 divided by anything is always 0. And don't forget to flip the inequality symbol because we divided by a negative number. The result tells us that the input can be any value 0 or below. If you test a number above 0, you'll see that you end up with the square root of a negative number, so it doesn't work. Let's look at the graph of this function. As we saw from our calculations, the function only exists starting at 0 and going left. It can't go to the right of 0 because those inputs don't create a valid output. So our domain restriction perfectly matches the domain of the function's graph. All right, here's our next example. What here might cause a domain restriction? That variable down to the denominator. Remember, only the denominator matters. These variables in the numerator won't create a domain restriction. We only need to worry about the denominator. So what's the rule? The denominator can't be equal to 0. So we insert the denominator and solve by subtracting 2 to get the domain restriction. J is not equal to negative 2, meaning that any input is fine as long as it isn't negative 2. Let's look at the function's graph. Can you see why negative 2 is excluded from the domain? It's because of that hole. There's a point at every single input except for where that hole is at negative 2. It's important to know that most calculators won't show you a hole in a graph. It's too small to actually see on the screen. Instead, what the calculator would show is this. This is why it's important to recognize what causes the domain restriction. Calculators aren't as smart as you. Here's our next example. What might cause a domain restriction? Trick question, there isn't one. The variable is in the numerator, not the denominator. Since there are no restrictions, the domain is all real numbers, meaning every number on the number line. If we look at the graph, we can verify that there are no holes or stopping points. There is a point at every possible input. One final example, and this one will be a little harder. I know it looks a lot harder, right? But if we apply the domain restriction rules, it won't be hard at all. First, we've got this variable inside of a square root, which means that we have to use the square root rule, radicand greater than or equal to 0. We only have to worry about the part inside the square root. Everything outside of it doesn't matter. We plug in the radicand and solve by dividing by 3 on both sides. X is greater than or equal to 0. And we're done. Wait, no we aren't. The function also has a variable in the denominator. So we're going to have to use the rule denominator is not equal to 0. Again, we only have to worry about what's in the denominator. All that other stuff on top doesn't matter right now. So we put the denominator where it goes, and notice we put the entire denominator in, not just the term with x, and solve. Add 2 to both sides, then divide by 2. X can't be equal to 1. Now to put these two domain restrictions together. The domain includes all numbers 0 and above, and the domain does not include 1. So if we put them together, we get the domain is all numbers 0 and above except 1. Let's verify this using the graph. On this graph, we can clearly see that no inputs to the left of 0 can be used, and due to that hole, 1 can't be the input either. But every input between 0 and 1 and every input between 1 and infinity work just fine. Once you know how to use the rules, finding domain restrictions is easy. Keep practicing on our website. In the next video, we're going to look at why domain restrictions exist and how they can occur in real life. See you then.